Hello, everybody, and welcome to Dot to Dot. Today, I'm going to talk about the Triangle de Pierre on Zena Halpern's map, which is located right here, and the stone triangle. Now, I'm going to give you some evidence, geometric evidence, that will show that the stone triangle that used to be on Oak Island, it was taken away in 1966 by Robert Dunfield, but this stone triangle is the Triangle of Peter, or the Triangle of Rock. So let's go to Google Earth. And recently we have been working with these vectors from cone C to cone A that brings you down to a point near the garden shaft, and also cone E to the large boulder, or what I call the rose stone, which gives this point right here. Now, I believe, and I'm using the dimensions that were given by Fred Noland, and Brian Farrow, he used a different set of dimensions, and his point was out here, but mine lands right here, which is basically the exact point of the drilled rock. Now, the drilled rock was a rock that was due north, straight due north from the stone triangle. And here's the stone triangle right here. Now, this location is based off of two 1937 surveys overlays, Robert Restall's survey and the 1931 aerial. I'm very confident of this location. So the Triangle of Peter, which is on the landmark map, at this location, it basically just gives us a termination point of this 45-degree angle, which comes off of cone A. Now, this orientation of this 45-degree angle comes from what's called the landing on the Rochefoucauld map, and I'll show you that in a minute. But one thing we can see is that this is an icon with a 90-degree angle and a 45-degree angle here. Also notice that it goes the pointer points at almost a true north direction, very similar to this stone triangle. So this is very interesting. Also, this little lightning bolt also points up to the north anchor, and you're going to see the association with that in just a minute. So with this intersection of the true north from the stone triangle to the 45-degree angle, we can look at the association with that, with the rose stone, the large boulder here, and L'Hamp. This is a center point, and this is 600 feet. So these are equal distance, 600 feet, one from another. So that's 600 feet, and that is 600 feet. So if you take another 600-foot circle and you go to the L'Hamp, it goes to the north anchor. There's that line for the rose stone. So we have a equal distance from the rose stone to the north 45 intersection to L'Hamp to the north anchor. So, but this is not associated with this right here. It's associated with the stone triangle. So is the stone triangle really the Triangle of Peter? So another association is from cone E to the drilled rock, it is 1,444 feet, which is the same as 1,347 pied. That distance through the landing is the exact distance from the north anchor to cone E. So if we take let's take this off here. If we take a 600-foot circle from cone E, it goes through triangle 2. Very interesting that this triangle has a link of 600-foot, three 600-foot circles that end up at triangle 2. Now, we're talking about here cone E and cone A are the main vectors for this series here. Now, on my last video, I did this, and if you take a circle around cone E and cone A, and you find the center, oops, that thing flashes sometimes. That's weird. Let me turn that off. If you find the center of that circle, you find that if you go from triangle 2 through the center of that circle and follow it down, it ends up at the stone triangle. So there's a connection between the stone triangle and triangle 2. Now, you remember that, let me take some of these off here. If you remember on the landmark map, I'll put the landmark map up here. Let's see, where is it? It's up here. You remember they have similar icons. Okay? And notice the 90-degree angle and how it sort of conforms to Nolan's cross. So if we take let's see, I have it here. Take a triangle here. Notice how they're similar. Now that's just a clue. I think it's just a clue that maybe associates with this geometric function of this circle and the center of this circle, to where it associates with the stone triangle. So another thing I want to show you too that is associated with the stone triangle, let me take the landmark map off and let's put on the Rochefoucauld map. Now here's the Rochefoucauld map, and let me take these off too. And you can see that the Rochefoucauld map is oriented in a way that from cone A, the 45-degree angle is through this north arrow here. And it goes, that's what creates the 45-degree angle. Also, notice L'Hamp is the center of the quadrant. Now, this orientation is given through what's called the landing, and the landing is right here. And when that is interpreted through the landing, it gives us let me put the landing up here. It gives us this geometry to where you have a point that is discovered through cone C to this set point, and it ends up over here on Frog Island. So that is the landing here, and it goes through and it ends up over here at Frog Island. Now this distance from Frog Island to here is 3 times this distance from here to here, which is the 1,444 foot distance. So this is a function, the landing is a function of orienting this document to these 2 points. Now the round island cone is these 2 rocks right here, and it is due west of La Hampe. And this line is determined in this document through this association here through this V, which is the solution to this riddle that is in this note right here that was discovered by Olivier from Oak Island Research. But the connection to the stone triangle to this is that if you take a vector from the stone triangle to Frog Island, and you take one from to Round Island, and you find that these distances from the Frog Island point, I got to put that back up there, I guess. Let's see. The Frog Island point and the Round Island point are the same. So this distance, these two distances, one, they're both the same. 4,221 feet and 4,221 feet. So from the stone triangle, we have an equal distance. That makes the stone triangle the origin of the alignment of the Rochefoucauld map and the landing, which sets up the 45-degree angle, which basically sets up the area in which the first entrance into the tunnel will be discovered. This is just the geometry that leads you to that point. And the association with all the different landmarks is the construct of this geometry. This is not something that will be surveyed. This is all map work that is done prior to landing on the island. It just gives you the indication of where all these landmarks are so you can find the entrance into the tunnel to the vault. So that's what I have for you today. Thanks for watching. Like and subscribe, and I'll talk to you later.